Garrett just joined in. So Garrett, you need to check attendance. Your password for attendance is database, small word, database. Garrett, can you hear me?
Yeah, I just changed from my phone to my laptop.
Oh, okay. So you already checked attendance. Okay.
Yeah, I got it.
So now let me open up my PowerPoint. So this class is about about a database. So we need to understand what is database, right? So first we need to know probably say what is data, what is information, what's knowledge. Those are three common terms people are using almost every day. Let me enable that. Oh, what is that? Okay.
Will these slides be posted online?
Yeah, this slide is already posted online at eCourse.
Okay.
So we just follow that. For first few minutes, we're going to follow that, okay? But you need to watch me and then listen to me explanation, listen me to explain, and then I may switch back and forth from PowerPoint to other programs, okay? So let me do slide show here from beginning. Okay, so first of all, let's just have a simple clarification of data, information, and knowledge. Data is simply just a recorded fact. Just say when you have some kind of object, you make observation. That observation is called data. Okay, and data is typically when you make observations, you pick up some kind of object, for example, a projector, or computer, or student, or customer, or account, and then you make observations in many different dimensions of the object. For example, a student typically will have student ID, student last name, first name, student street address, city, state, zip code, and student GPA, student major, right? So you're going to have many observations. So you put all these observations into one like array, one place, like we call array or collection. That would be called a record. A record is a very important concept in database. It's just a basic storage or data organization unit or database. Okay, so we are talking about database. Just a second. Database is not just simply a set of data, but actually data has to be organized. And the way to organize it is the basic unit of storage is array is called a record. A record is just an array of observations made on one object. Is that clear? Okay, so for example, I have examples of some records. So here, the first one is a student record, I believe, right? So John Doe, and the birth date, and the street address. Second one, this could be a customer. Okay, customer record, Lisa Smith, and birth date, and the street address. And also have two like account records. So each account has an account number, account type, and a balance, right? So all those are basic units are called records, and they are just basic unit of data storage in database. Is that clear? Yeah. So make sure that the records are all observations made on one object. One record is for one object, okay? Two records for two objects, okay? And then what about information? People talk about information, and we call this database class, not information base, right? But sometimes people talk about information. Is information same as data? To me, information is just like a processed data. Data has been already processed, okay? And similarly, we also use knowledge, use a term called knowledge. What is knowledge? Knowledge is just the data or information presented in a minimal context, then become knowledge, okay? So that basically just gives distinction of the three interchangeable terms. People online, do you have any questions? Can you hear me well?
We can hear you.
Okay, so you can follow me well, right? Okay. So if there's any time you feel disconnected, just make sure you stop me. Now, what is database? Once again, database, this is a concept. In year 310 class, 310 is information, what is it called? Management information. or information system for manager, something like that, okay? In that class, the textbook may give you a cut-down definition of database is like a common repository for people to share data. That is not a very scientific definition. The definition I'm going to adopt is this. It's a set of records. Remember records, okay? Well organized. Okay, that's the second keyword. Has to be well organized. Otherwise, you have junkyard. It's not database, okay? And then when you do organize, you have to have a framework to organize, right? That framework is called logical data model. So logical data model is just simply a framework to organize records, okay? So that is the definition of a database. Okay, so we understand records, and then we understand, we basically have an intuition of, so what does it mean by organized, right? But so what is logical data model? So we'll be talking about that. Okay, so well organized. So what are the key requirements to be well organized? The well organized, there's basically two requirements. The first requirement is that all related records must be connected so that from one record, we can navigate to related records. For example, if I have a customer record, I should be able to find his or her account records. Make sense? If I have a student record, I should be able to find what courses, what classes that student is taking. Okay, I should be also to find which dorm the student is living in. Okay, so the records must be connected so that you will be able to use database to trace from one record to a related record. Okay, and then the second requirement is not very clear at this point, but you can use your common sense. Basically, you do not have unnecessary redundancy. So for example, one piece of data should not be repeated at some different places. Why? Because if you have that kind of redundancy, then managing data is going to be a nightmare. So for example, a student major has in one place, second place, third place, have majors. But if you, for example, you change the major in once, but then you don't change other places, then the student will have multiple majors in the database, right? So that way you have data inconsistency problem. So data unnecessary redundancy will be unnecessary redundancy will cause a lot of data inconsistency problems and some other problems too. We'll have 1 week to talk about that. Okay. Now, how to organize records? Of course, you're going to use a framework. That framework called logical data model. So I'm going to explain a couple of examples of logical data models. Okay. Now, logical data model. So in the old days, when we talk about old days, it's not that old in terms of time, probably just 20, 30 years back, okay? We were using some kind of logical data model called hierarchical model. This is a hierarchical model. This is hierarchical model. Okay, so what does that do is basically all the records will be like connected by something called pointers, okay? Starting from like empty root does not have any record. And then all the records will be connected, organized like an inverted tree, okay? Connected by pointers. So what is the pointer? The pointer is a concept. If you have taken C++ class in computer science, I think some students choose C++ instead of 315, right? So if you choose the C++ class, then there's a concept called pointers there. Has anybody taken C++ class? No? Okay, so anyway, it's a programming concept. It's basically just like a kind of like address for variable. Okay, so I'm not going to explain that. So anyway, you understand that. So by using that pointer concept, you will be able to connect records through pointers. And then to find the record, you basically starting from the root, empty root, and then you find the first level record, and then you navigate to the related next third level records, and then going down. So all the records will be connected as such. Okay. Now, when you do this, there's one restriction. The restriction is, for example, we have two customers, John and Bill. Okay, two customers. They both they share the same account number 13 with a balance 450. You see that? That is problem for hierarchical model. So what is the problem? The problem is these records have to be repeated twice. Because otherwise, if you connect this, for example, Bill to here to this one, you're going to create a loop. You're going to have a circle. And that is not allowed in the tree, right? Have you ever seen a tree with loops? So that is not allowed. So basically, hierarchical model will not allow loops. So because of that restriction, so sometimes you may have to have the duplication of records in the same database. Okay, so that is that's a hierarchical database. Okay, I think I already okay. So here, just give you a little bit of history here. So the first commercial database system proposed on the hierarchical data model was IBM, 1968, okay? And it was part of Apollo project, NASA's Apollo project. And the limitation, okay, I said that like a real tree, no cycles of linked records are allowed. Okay, so if Bill and John have the same record, same account, then you have to duplicate that account record to connect to John and Bill separately. Okay, and another restriction is that because using pointers in older days, at that time, people have to use programming language like a COBOL to be able to create a database and manage a database. COBOL is a programming language, okay, and which has concept of pointers. But today, I don't think many people know COBOL anymore. So about 20 years ago, when I taught this class, one of my students got a job doing COBOL, awful. I told him not taking the job because the database is kind of getting obsolete. So if you take the job, you spend a lot of time to work on it and gain experience. And then after a couple of years, your experience becomes useless, right? So today, except that a few companies are using COBOL for their legacy databases, for maintaining their legacy databases. Otherwise, there are not many jobs in using hierarchical database. Okay. Next, because of the restriction of this no cycle thing, then there's a next model. It's called a network model. So network model does allow you to have cycles so that you don't have to duplicate the records, like the account shared by two customers. You can, create cycles. Okay, of course, the query becomes more complicated. It's more time consuming. Okay, but it has a. The other day I look at here, but some people still saying that this is not a bad model. Network model is not bad. They're still using network model, but instead of connecting records, they're so-called using the network to connect so-called objects. Okay, so this is how just kind of like a hierarchical model is still using pointers, but instead of no cycle, instead of like a tree, you can link those records like a network. Okay, which allows you to have cycles or anything. Make sense? Okay. This network database was proposed in around the 1970s by this guy called Charles Beckman, and later we will learn something called the relational model, which is actually a diagram proposed by this guy, Charles Beckman. Okay. And also limitation is, you still have to use concept of pointers. So basically using programming language like a COBOL or C++. Okay, so layman people, for example, your human resource managers will not be able to understand, or will not be able to create and manage COBOL, create a network database. So you have to have a programmer to do it. Okay. Now, relational model is what we will be doing in the first part of the class. So in this class, we are going to cover a couple of different databases. Major one is relational database. And after that, we'll do so-called NoSQL database, which is a non-relational database, okay? So relational model basically is So you have records, you still have records, but you stack all these records into a table. So record for customer record, you make all the customer records into one table, and that table is called the relation. Okay, why is it called the relational database? Relational model is just because those tables are called the relations. Okay, so I will give you an example for that. And each table consists of multiple columns, which is like fields, which we can call them fields or attributes, and the rows. Each row is a record. Okay, so unlike a network model, hierarchical model, the relational model links records by sharing common IDs. I'm going to explain to that. So instead of using pointers to connect records, we will use common key values to share records. Give you an example for that, okay? So here, so I have two customers, right? John, Bill. So these two records will be stacked together into something like this, and this is called a relation or a table, just same thing, okay? So it's just table is layman term, and relation is academic term, okay? And then there's another term which is used by industries called file, data file. So all the days, each table is like each of these will be stored as a file. Okay, so basically we may use those three terms interchangeably: relation, table, or file. Okay, and each table has rows. Each row is also called a tuple or record. Okay, three terms again. And each table also have multiple columns. So each column is called a column or field or attribute. Three terms, basically used by three groups of people. People doing like universities, students and the professors, they use academic terms. And then layman people will use tables, rows, and columns, right? And then data processing field people will be using file, file record, and field. So each one is called a field. This is field. Okay. So now we have two relations, two tables, basically. Okay. So you stack all these account records together into accounts table. You stack all these customer records into this account table. Okay. Now the question is, without using pointers, how do I know which customer has which account? How do I know that which account does John have? Which account does Bill have? Or reversely, how do I know that account 13 belongs to whom? And account 25 belongs to which customer? So in other words, without using pointers, how can I tell how these two set of records are connected? Do you see the problem? Do you have a solution? Yeah. Yeah, so you're going to use a concept called the primary key, but without using the concept of primary key, what's your common sense? What is your intuition? Well, the intuition is simply like this, right? So for example, if I put like when I have an account here, right? So if I put Bill in here and John in here, okay, I create another column, for example, and then have a Bill and John like that. I will be able to tell which customer has which account, right? Another way to do that is instead of put John and Bill in here, I can also put account number into this table. So for example, first one, I can have another column called account number, and John has account number 13, Bill has account number 25. That way, I can also find which customer has which account, right? So you can have either of those two approaches. And then for this problem, those approaches probably will fail because what? So John, what if John has two accounts? What do we should do? Can you put a 13 and comma 25 into here? People online, can you see my mouse moving? People online, can you see my mouse moving?
Yeah.
Okay, good. So for John, for example, if I say John has both account 13 and 25, what should I do? you can use in spreadsheet you probably say 13, 25, but not in the database. Why? For spreadsheet we use our visual eyes to see this these two account numbers and has a comma inside, right? But then when you put in the database are not meant for people to see. It's meant for machine to search, to query. Okay, so machine will interpret that as, let me write. Hold on. So how do I do whiteboard? Now the whiteboard is not available here. Whiteboard. Let me just use Paint. Okay, so suppose I have account number 13 and account number 25. Okay, that's account number. Account number here, this column, right? Okay, let's just say John here. Okay. So that's his name column. Okay, so I can say John has this account, and now what if John also have account 25? So it's tempting to do something like this: 13, 25. That in spreadsheet is okay because we can tell John has two accounts. However, in computer, in database, you cannot do that because the whole thing will be considered as a one account number. Okay? And you understand that a computer store everything like a binary numbers, right? 0, 1, 0, 1, 0, 1, 0, 1. Okay? So computer will make this maybe like so I'm just pretending. Okay, this maybe this. Oh, what happened? What happened to my pen? This bad pen. Oh, okay. Let me. Oh, this is bad. Oh my gosh. Okay. So anyway, what I want to see is the computer will store 25 as set of binary code, 0, 1, 0, 1, whatever. And then 13, 25, 35 as another set of binary code, maybe 10, 10, 10. And the computer will not interpret that as combination of two account numbers. Okay? So there's one restriction in the database. We will be spending time to talk about so-called normal forms. That is, each cell can only have one value. You cannot have two values combined by commas or any other symbols. Okay? So that is the problem for our case. For our case, let me go back to the PowerPoint. Okay. In our case, I cannot just say here and then this is John, then has account of 13, 25. And then Bill has account 65. I cannot do that. So what about the other way? I put a Bill here and John here and the Bill here. What if the account 13 belongs to both John and the Bill? Same problem, right? You cannot say Bill, John or John, Bill. All right. So in this case, how do we connect? Well, actually, we have 3 different ways to connect. Let us show from current slide. Okay. So you have 3 different ways to duplicate so-called ID values. So previously, let me go back to the previous one. So this for customers, the name is like a key value, like ID, right? Each customer has a name unique identify each customer. And for account, each account number is a key value, is ID value. So with this account number is ID. And then how do you duplicate the IDs? Well, there are 3 different ways. You can duplicate the customer name into accounts, or you can duplicate account into customers. And there's still another way to duplicate. You can duplicate key from both tables into a third table, like this case. So I duplicate the name into here, and I duplicate account number into here. So now this is like a third way of duplicating the key values. And this approach probably will be working for us. And so, for example, John owns this account 25. John also owns 13. 13 also owned by Bill. So I can just create a separate shared records like that. Okay, so basically 3 different ways to duplicate the key values or ID values. And by using this duplicating key values or ID values, now the original record will be connected. So now you'll be able to find, for example, who owns account 13? Who? Look at 13 here, owned by John. So now you find John's record, right? Make sense? So account 13. 13 is this account owned by John, so John is there, also owned by Bill, so you find the Bill. Okay. Now, conversely, which account does Bill have? Look at the Bill. Now, if you go to this third table, Bill owns account 13 and 56. Account 13 and 56. So now you should say that Bill has approximately what? $800 in balance total, right? 2 accounts. Is that clear about how the relational database connecting different records without using pointers? Now, by using so-called this duplicate ID values, I'm introducing 2 important concepts for this class. First of all, the key for each record, the ID for each record is called a primary key. So for example, the name is a primary key for this table, and account number is a primary key for this table. Okay? And then on the other hand, the duplicated primary key will be called foreign key. So now this name is a foreign key because it's a duplicate ID from customers. Account number here is a foreign key because that is duplicated ID from this account table. Okay? And so this is the definition for the 2 keys. ID of each record is called a primary key. Simple, right? And then duplicate primary key is called a foreign key. Okay? And then in the relational database, this is how summarize how data are organized. Records are organized in the bi-relational model, which connect related records by duplicating primary key values into foreign key values. Without using pointers, relational database or connecting records by duplicating primary key values into foreign key values. Okay. Now remember, we have 3 different ways to duplicate the primary key values. Duplicate from one side to the other side to this side, right? So we can just do either way, or we can do a third way, which is duplicating primary key in the third junction table, third table, okay? So which approach to be used? That really depends on concept called a mapping cardinalities. And we'll be talking about that a little bit later, okay? So it depends on how the records are related, okay? The quantification of the relationship is called the mapping cardinalities. Okay. Now let's talk about database development a little bit, and I will be jumping into how we design database after that. Okay. So to design a database, first thing we need is a tool. What tool do we need? Okay. Of course, you need to use a computer, right? And you need to use a computer which has this program called DBMS. DBMS stands for Database Management Systems. Okay, so it's basically a program, computer program, for us to create new databases, secure the database, and manage database. Okay, so after create database, we put data into it, and then we have to make sure data is secure, and also we have to make sure that we can find the records or update the records in the database. Okay, so that is what the DBMS is all about. So examples of DBMS, Microsoft Access. You probably already had some experience, right? In 3.10. That's a very low-end database. And then Oracle, very high-end. Okay. And in the middle, we have some other choices like MySQL, which is a free DBMS. Basically, everybody can download for free. It's open source software. And then Microsoft SQL Server, which is also in the middle range. Okay, so some kind of like connected, have some kind of flavor of Oracle and some flavor of Access. That's my SQL Server. SQL Server. Okay, and then after you have DBMS, then you're going to use a programming language to talk to the DBMS. And that programming language, in the older days, we use COBOL. I told you that, right? And now we use something called SQL, structured query language. So that's what we're going to learn in the second period of this course. We spend a lot of time on that, right? So people learning data analytics, you probably come to this class just because you want to learn SQL. Okay? And SQL, JavaScript are two of the most important skill for looking for jobs on the market, for this market. Okay? So that's the tools. What are process? The process is basically 3 steps process. The first step is so-called data model. You're modeling the business data requirements. Okay? And then you're going to convert that data model into logical data model. Remember, logical data model is a way to organize data, right? So here, logical data model will become some kind of specifications for database to be developed. And finally, you're going to write SQL statements to implement your logical data model into database. So basically, that is 3-step process: business data model, logic data model, and database. Okay. So let's just briefly go over that, and then we're going to spend more time on Friday on how to create business data model. And let's just go over this quickly, just the overall process. So first process, for business data model, you're going to understand what are your business objects on which you're going to make observations and organize their data, record their data. So for example, for university setting, you probably have to have data on students, right? Professors, right? Buildings, classrooms, right? Courses and sections, right? Dorms. Make sense? So that's university setting. Now, if you talk about some kind of online system like Amazon, you probably need information on their customers. The customer will be their objects, right? Information about orders, information about their products, right? Information about the shipments, information about trade and returns. Okay, so those will be their objects. Make sense? Now let's pick up one more example, say in the bank system, customers, employees, accounts, transactions, right? Branches. Okay, so those will be their business objects. So you identify those business objects, okay? And then for each type of business object, for each customer or for each student, you want to say what data you want to observe. For example, for student, I want to have your student ID, right? Definitely. I want to have your name, last name, first name, right? I want to know where you're from, right? So like a state, right? And I will also need your like a phone number or maybe email address. What about your height? What about your color? They are attributes. They are properties of you. However, for registration database, probably we don't care about this, right? But for university clinic, they probably do care. They probably know what's your height, what's your weight, what's your blood pressure, all that, right? So it depends on the database you develop, the attributes, what is important characteristic to be observed, depends on the purpose. Make sense? Okay. And then you identify the relationship that connect objects. So for example, in the real world, objects are related, right? So student take class, right? This building house classroom, right? Customers take orders. Professors teach class. You see the relationship? So that's how objects are objects related, right? So basically, you are going to identify those relationships, see how they are connected. And then based on all those three things, you develop so-called business data model, okay? And which will represent so-called data requirements for the business. Okay, so that's step one. Step two, you convert the business data model into logical data model. In our case, will be relational model, okay? Or in the old days, we'll connect to so-called hierarchical model or data or network model, okay? So you convert business data model into logical data model, okay? So basically, you're going to convert those objects into records. And then you're going to duplicate primary key values into foreign keys, depending on the relationships. So for example, between customer and account, one customer can have many accounts. One account can belong to multiple customers, like joint accounts. Then you have to create for table to duplicate those key values. Okay? So that basically depends on the relationship. And then finally, you're going to use a programming language such as SQL to implement the logical data model into relational data into database. So this is the three-step process. Okay. Just make sure we talk about data models, two kinds of data models so far. Logical data model is used to organize records, right? Business data model is used to capture data requirements. Make sense? So make sure you have a distinction of these two different kind of models. Okay. And little bit about the concept of our model. A model is just simply abstract or simplified representation of realities. So reality is simple, is very complicated, right? Or human being. Or human being is more than student ID, more than a name, more than a major, right? It has a lot of different phases, right? So it's very complex. But however, when we do model, we make it a simplified observation of the reality. Okay? We take a side, take a viewpoint, and then we ignore non-significant stuff and only take what is essential, put in the model. Okay? All right, and then let me, so this is what we're going to do next. So on Friday, we'll be doing something called entity relationship diagram. That is an example of business data model. So there are several different kinds of the business data model you can use, but in this class, we will exclusively use entity relationship diagram as an example of database, as a business data model to capture data requirements. And it's basically just a graphical representation of objects, entities, and their associations with relationships. Okay? So this is example of ER diagram here. So we have customers, our account, and then transactions and the employees. So those boxes, so you see that each box, the employee box, have attributes listed, employee ID, employee last. I should use my mouse because online people will not be able to see my finger pointing here. So employee, as employee ID, employee last name, employee job. Okay, customer ID, customer name, and the state. So all those attributes. So I will explain to you what are those things. So this diagram is drawn by data modeler. So we'll learn how to do that on Friday. Okay, so I'm going to stop here. Let me say whether you have any questions. Anybody from online, you have any questions? No questions? Anybody here have questions?
I have a question.
Yeah.
So all of the homework that you have for us is going to be due the same day that the homework is listed to be due on
Yeah. All homework, but those parts will be due at the same time. So online questions, you can just try it now, and then maybe try it tomorrow again. Try a couple of times, right? And then make sure you finish that before the due time, because after the due time, you will not be able to do it. Okay.
Okay. Thank you.
And then for online submissions, if you submit after the due time, you will be marked as late. Okay, the system will automatically stamp your homework as late. Okay, So make sure both of them must be done. So as a learning, just give you some my experience. The best time to finish homework is immediately after class. You know why? I found that I spent way less time to do homework, to finish homework than a few days later. Okay, so that's my learning experience, my own experience. So make sure, I think, maybe today, after today, you can try some questions. You'll be able to finish, right? And then Friday, after we finish class, you should try to finish the entire thing, Friday. Then that way you give you enough time just in case you have questions to ask during the weekends, right? Or reconsider some of the choices. After exam, after class, you still have fresh memory of everything we did, right? So that time you will be most efficient to do homework. All right. Any other questions you may have? All right. So I will see you Friday, everybody. Just email me if you have any questions. Right. So I think one student have problem with data modeler downloading. Right. So I will work with you just after this. I'm going to stop recording. Stop sharing. Oh, you too. Thank you. Question? Next Monday before class. Yeah. Say it again.
Are we going to have a tutorial on how to use the data?
Yeah, we have not covered database yet. So basically, we have not. So last class, we just basically did a setup. And today, this PowerPoint, that's what we have covered so far. And then Friday, we'll be doing data modeling. Okay, so we have not get into database yet. Yeah. 56. Oh, that's wrong. That's wrong.
Okay.
It should be 65.
It should be 65.
Yeah.
And
Thank you.
then just to clarify, homework's due right before class.
Right before on Monday. Yeah, right before next Monday's class. Yeah.